the end of this lesson, you'll be able to use the counting principle to find the number of outcomes in a situation and to find the event that one of those outcomes would occur. So let's say in a closet I have a red top, a blue top, and a white top, and a pair of pants and a skirt, and I want to know the number of possible outfits I can make. I can do what's called a tree diagram. In a tree diagram, you actually write out a visual representation of the number of outcomes. So I could say I have a red top, I have this blue top, and I have a white top. In the red top, I can wear the pants or the skirt. The blue top, that can be split up. I can use the pants or the skirt. And then the same thing with the white top. I can wear pants or a skirt. So now I can go down this list and count the number of outcomes. So I have 1, 2, 3, 4, 5, 6 possible outcomes. Okay, so the red top, there's 2 choices. The blue top, there's 2 choices. And the white top, there's 2 choices. All right. Again, that's called a tree diagram. We can also do a tree diagram if I want to know the possible outcomes if I flip 3 pennies. So in my first flip, I can get a head or a tail. And then the second time, let's say I get heads first, I can get a heads or a tails second. And tails first, heads or a tail second. And now here's my third flip. All right, heads or tails for each of these. Okay, so now again, I can count my number of possible outcomes. I could have 1, which is all heads, so heads, heads, heads. 2, heads, heads, tails. 3, heads, tail, heads. 4, heads, tails, tails. 5, tail, head, head. 6, tail, head, tail. 7, tails, tails, and then heads. And then finally, 8, tails, tails, tails. So that has 8 possible outcomes. So you can use a tree diagram to find the number of possible outcomes. Another method that you can use is called the fundamental counting principle. All right, so we use what's called the fundamental counting principle. Right here. All right, and what you can do with that is because sometimes, let's say you're throwing like 50 coins, you don't want to write all those possible outcomes out. You want a quicker way of doing it. Or if you have like 20 tops and 15 pairs of pants, you don't want to write out all of those outcomes. So we're going to think of a quicker method to do that. So you can use what's called the counting principle, where you count the number of possibilities of one set and the other, and then you multiply it together. If you just heard my cat meow at me. All right, so I have 3 tops, and then 2 choices for bottoms, and I just multiplied that together, which is 6. So again, 6 possible outcomes. So each tops has 2 possible bottoms. If I want to do the 3 pennies that are flipped, I have 2 choices for the first flip, 2 choices for the second flip, and 2 choices for the third flip. And then 2 times 2 times 2 equals 8. So instead of having to write out a tree, although it's kind of nice to see, hey, to look at all the possible outcomes, if you just want to know the number of possible outcomes, the quickest way is fundamental counting principle. But again, a tree diagram is helpful if you actually want to visualize or see what those are. So if I do 2 times 2 times 8, or sorry, 2 times 2 times 2, which is 8, I know there's 8 possible outcomes. But if I want to know what all of those outcomes are, like heads, 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 or heads, tail, heads, the tree diagram is helpful for that. So we're going to use the fundamental counting principle to find the total number of outcomes in each situation. So it says 1, 6-sided number cube, I guess, or dice, if you will, and one card is chosen from a 52 card deck. And I want to know what are the different combinations that I can have. Could I have 1 and ace of spades, a 5 and a queen of hearts? What are the different choices that I can have? So 6 for the number of sides in the cube, and then 50 times 52, the number of cards in the deck. And that gives me, there's 312 different combinations that I can have. So 312 different outcomes. So I could have a 5 and the 10 of spades. 10 of spades? That sounds weird. Yeah, 10 of spades. All right. Number 4, one letter and one digit from 0 to 9 are randomly chosen. So I could get an A and a 5, a F and a 0, a G and a 9. So what are the different combinations there? So there's 26 letters in the alphabet times 10 digits. So that would give me 260 different choices. And I wanted to add one more. I guess we'll call this 5. What if I wanted to do an 8-digit code? What are the different, how many different codes can I make if I make my code 8-digit code? So not an 8-letter code. If it was an 8-letter code, then I would do 26 and multiply that 8 times. But an 8-digit code. There are 10 digits, so I know I'm going to do 10 times 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 10. Or you can even write that as 10 to the 8th because I multiplied 10 8 times. So that's going to be boop. 1, 2, 3, boop. It's going to be 100 million different codes. And that's if I just use numbers. All right, so there's tons of different codes I can make for that. Okay? So, fundamental counting principle, you multiply the different, how many are in each category, and you multiply it together. So 6-sided cube times 52 cards. 26 letters times 10 numbers. 10, and then for the 5th example, 10, 10, 10, 10, 10, 10, 10. I'm 10, 10, 10, 10, 10, 10, 10, 10. I gotta make sure I say enough tens. All right, and multiply the 8 tens to find out how many different choices for an 8-digit code. So sometimes you want to find the probability that an event can occur. Okay, so probabilities are written as fractions. On the bottom of your fraction, your denominator, it's the possible outcomes. Okay, so the number of possible outcomes. And on the top, you're going to put that event occurs. Okay, or number, all right, the event that occurs. So, what I mean by an event, if I say, what's the probability of getting heads when I flip a dice? I have a 1 out of 2 chance because the number of possible outcomes are 2. I can get a heads or a tails, and the event is getting heads. If I want to know the probability of drawing the ace of spades from a standard deck of cards, there's only one ace of spades in the deck of cards, and there's 52 cards. So there's 52 possible outcomes and only one ace of spades. So I have 1 out of 52. That's the same as question 11. What is the probability of drawing a 6 of clubs from a standard deck of cards? Still, there's only one 6 of clubs, and there's 52 cards total. For number 10, it says a coin is tossed twice. What is the probability of getting 2 tails? This one I actually found it helpful to write out. There are 4 possible choices because it's 2 times 2, which is 4. And I do know that there's only one way of getting tails. But it might be helpful for some of these to write it out. So I can get heads and heads, heads and tails, tails and tails, tails and heads. So you notice there's 4 possible outcomes, but only one of those is tails and tails. All right, but again, if you're doing the counting principle, you know it's 2 choices for the first flip, 2 choices from the second flip, and only 1 chance of getting tails both times. Number 12. Roll a 4 or higher on a 6-sided number cube. So there's 6 possible outcomes. The number of events that can happen, you can roll a 4, because that's 4 or higher, roll a 5, because that's 4 or higher, or roll a 6. All of those numbers are 4 or higher. So that's 3 events. When I look at this fraction, it can be reduced. I can divide those both by 3, and I get 1/2. So I have a 1 out of 2 chance when I roll a 6-sided cube to get a 4 or higher. For number 13, roll a 7 or an 8 on an 8-sided die. So I have 8 possible outcomes, 1, 2, 3, 4, 5, 6, 7, and 8. And 2 of those are 7 or an 8. And again, that can be reduced because I can divide them both by 2. So I have a 1 out of 4 chance of getting a 7 or an 8. What are the chances of rolling an even number on an 8-sided die? Still, there's just 8 choices. The even numbers are 2, 4, 6, and 8. So there's 4 even numbers, and that reduces to 1/2. What is the probability of drawing a club from a standard deck of cards? So there's 52 cards in a deck. A set of cards has 4 suits: club, spade, diamond, and heart, and there's 13 of those. So there's 13 clubs in a deck of cards. There's 13 clubs, there's 13 hearts, there's 13 spades, and there's 13 diamonds. So I have a 13 out of 52 chance, or 1 out of 4. The other way you can think of it is there's 4 different suits, so there's 4 different possible outcomes. There's the heart, the club, the diamond, or the spade, and only one of those is a club, so 1 out of 4. So either way, you're still getting 1 out of 4. What's the possibilities of rolling an odd number on a 6-sided number cube? So again, there's 6 possibilities. Your odd numbers are 1, 3, and 5, so that's 3 of the 6, which reduces to 1/2. A coin is tossed and an 8-sided die is rolled. What is the probability the coin lands on tails and the die lands on 2? So we have of different choices. It's an 8-sided die times 2 choices, 8-sided die times 2 sides to a coin. So there's 16 possible outcomes. The probability that one lands on tails and a dice lands on 2 would be 1 of those 16 choices. The other way you can think of it is I have a 1 out of 8 chance of getting a 2 and a 1 out of 2 chance of getting a tail, and when I multiply those, I get 1 out of 16. A coin is tossed and a card is drawn from a standard deck of cards. What is the probability of landing on tails and choosing a red card? So if I land on tails, it's a 1 out of 2 possibility. And choosing a red card, half of my deck is red. So I can write it as 26 of the 52 cards are red. Or you can think of it as there's 2 cards in a deck of cards, 1 of those is red. Alright, so that's the way you can think of it. So what is the probability of landing on tails? 1 out of 2. And choosing a red card, that's also 1 out of 2. So when I multiply that, 1 times 1 is 1, 2 times 2 is 4. So I have a 1 out of 4 chance of that happening. So, counting principle. If I want to know the possibility, the different possible outcomes, then I multiply together my different choices in a kind of like the category. So, 26 letters times the number of digits. And that'll give me the possible outcomes. To find the probability of an event, you divide the event by the number of total possible outcomes, and you write your answer as a reduced fraction. So what you're going to do now is you're going to do 1 through, that looks like 1 through 12 to finish this section.